And we will find similar words. So given now a word, a tokenizer, and a model, we will return top 5K, okay? So we'll basically, given a word, we'll use the function getWord embedding here, which returns what? Which returns the embeddings, the vectors. Professor Muhammad returned the vector, okay, after the model has trained. So the numbers of these has changed. Now words find each other, okay? And we will say, okay, I want you to get these model.target embeddings. Detach and numpy, these are, ways to detach it from the GPU if it's detached to the CPU, okay? If it's detached to the GPU, it will detach to the CPU and just turn them into numpy, because if you want to make calculations on it and so on, it's in the tensor format. Remember, Pytorch is a huge tensor library, matrix multiplication and so, okay? So it's dealing with only tensors. If you need to work with something else, okay, you simply use .numpy method. It will turn it into numpy format, okay? Same number, same everything, but just another format. Okay, and within calculate what? Calculate the cosine similarities between all embeddings and target embedding. Now why is that? Because like we said, this is pure algebra, okay? You have a vector and you want to calculate the nearest vector to this vector. How do you do that? Cosine similarity, okay? Okay, oh yes.
Can we use different functions to calculate similarities?
Yes, any vector similarity algorithm. HSNW, but I don't remember the abbreviation, but it also can be used. Okay. And we'll simply do what? And we will simply do what? We will simply do, okay, we have now calculated that given this vector, calculate the similarity for the whole embedding, okay? We will simply take the top 5. So I sort them and I take the top 5, okay? And now, since I have now my top 5 vectors, what do? I turn them, I do now the process backwards. I have vectors, I turn them into IDs, I search for those IDs in the vocab, so I get letters and words, correct? Huh? So I get from numerical to letters and words again. So this is the conversion between our world and their world, okay? No? To increase, yeah, something like that, yes. Encoding and decoding, something like that, yes. So we'll simply do some test words, and these are the test words I have tried. Of course, it will not give you good results because I didn't train it that much. So you need to maybe train it for 10-15 epochs and see how the results are doing, or if they are good. Okay, so as you can see, King has Augusto imagery, which is non-relevant. I have made some other examples as well, but as you can see, they don't really have semantic relationship because we didn't train it enough. Okay, and I have here also another function that basically using Tisney, we are making the dimensionality reduction we talked about. We're moving these high dimensional vectors into lower ones, 2D ones, so that we can visualize them, okay? Simple visualization. Where is it? Yes, we're using Tisney here, okay? We are also using the higher API, so it's a high overview API. I'm not really implementing Tisney itself, okay? I'm just using, someone built Tisney and I'm using it, okay? So I am telling it, okay, please, whatever vectors you have, change them into 2 dimensions only. So if we have 100, right? We designed it to be in the embedding dimension to be 100, correct? So Tisney will reduce this 100 into 2 only dimension. Yes, exactly. And we will simply visualize. As you can see, this is the visualization. Some words, I think, yes, these words to visualize. Of course, if you train them more, you will find that similar words appear next to each other. Depending on how words appear to each other through the data set. Okay?